I start today's lecture by introducing binary coded decimal. Okay, this one is like a representing system. We show binary coded decimal with the abbreviation BCD. So BCD stands for binary coded decimal. And what is binary BCD coding? Let's say, assume we have decimal numbers from 0 to 9, decimal digits 1, 2, 3, 4, 5, 6, 7, 8, and 9. In order to represent number 0 in binary, we need only one bit, 0. In order to represent number 1, so these are decimals, and here we have binary. In order to represent number 1, we can represent 1 in binary with just 1 bit. To represent 2, we need at least 2 bits. 3, we need at least 2 bits. For representing 4, we need at least 3 bits. 5, 3 bits. 6, 3 bits. 7, 3 bits. In order to represent 8, in binary form, we need 4 bits, and 9 also 4 bits. So you see that we need different number of bits to represent decimal digits from 0 to 9. And it is not like a good idea to use different coding length. So it's not a good idea to use 1 digit, 2 digits for some decimal numbers and 4 digits for other decimal numbers. So here we can use a new numbering system called the BCD, or binary coded decimal, in which each decimal digit from 0 to 9 is represented by a fixed number of bits. So regardless of the decimal value, which we said can be represented by 1 up to 4 bits, regardless of the decimal digits, we represent all these decimal digits with a fixed number of bits. Of course, how many bits? We have to go with the highest number of bits, because if we use, for example, 3 bits, we can only represent up to 7. But if we use 4 bits, we can represent all 10 digits. So here, in order to represent number 0 in BCD, we show number 0 like 0, 0, 0, 0. 1 is 0, 0, 0, 1. 2 is 0, 0, 1, 0. 3 is 0, 0, 1, 1. 4 is 0, 1, 0, 0. 5 is 0, 1, 0, 1. 6 is 0, 1, 1, 0. 7 is 0, 1, 1. 8 is 1, 0, 0, 0, and 9 is 1, 0, 0, 1. So we use these BCD 4-bit coding to represent the digits of decimal numbers. Of course, with 4-bit binary numbers, we can go up to 15. So we can continue like a 1 0 1 0 1 0 1 1 1 1 0 0 1 1 0 1 and 1 1 1 0. So what should we do with these other possible combinations of binary codes? We say we don't care about these combinations. So we're not going to use these combinations when we want to represent a number in BCD. So we go up to 9. In order to represent number 10, in order to represent decimal number 10, so let's move to decimal number. So decimal 10, of course, in binary, decimal 10 is 1010 in binary. But if we decide to represent it with BCD, what we should do, what we need to do, we need to represent 1 in 4 digits and 0 in 4 digits. So 1 is 0001 and 0000. So it's the way that we represent number 10 in like BCD. If we want to represent number 25, okay, so of course 25 cannot be represented with 4 bits, so we need at least 5 bits to represent in binary. But if we want to represent 25 in BCD, we like show 2 as a like 0010 and 5 as 0101. Okay, so this one is the way we represent the decimal numbers in binary by BCD. So up to 0 to 9 we use 4 bits. From 10 to 99 we use 8 bits, and from 100 to 999 we use 12 bits, and we continue. Okay, so this one is a binary coded decimal system. And now I want to talk about an electronic display device which is called 7-segment display. 7-segment display. Okay, I'm sure that you have seen these displays in like around you. If we go to like work with electronic devices, we see this kind of displays that can that can show numbers 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And in order to show, for example, a number 2, we need to like we show it in this way, number 2. Okay, and one thing that I should mention, how it is built, how this display is built. If you look to this display, each of these parts, this part, this part, each of these parts are an LED that can be turned on and off individually. So each of these parts are LED. You see here we show a schematic which can be, by applying the field, can be turned off, turned on individually. So if we want to show number, show number 2 on this LED, we need to on this display we need to turn on these LEDs. Each of these LEDs have a name. So if we look to this view, we see that the top one has a name A, B, G, E, and D. So in order to turn on, in order to show number 2 on this display, we need to apply voltage to LEDs number A, B, G, E, and D. How we can apply? Just we have 8 input pins. These 8 input pins each are connected to one of these LEDs. Of course, we have 7 LEDs for the number. Okay, 7 for the number. We have 1 for the radix start, and we can have 1 for VCC and 1 for ground. Okay, so here we have total of 10 pins connected to LED. So let's see the schematic. If we look to a schematic, we see that we see the location of each input which is connected to any of these LEDs. So we have VCC in both sides. So in this type of LEDs we have VCCs, and of course we have like common dot point, and we have the inputs for the LEDs. This type of LED that I'm showing this example, this type is called common anode. What does it mean? It means that all the LEDs are connected to the VCC. In order to turn on any of these VCs, any of these LEDs, we need to connect the other side, the corresponding pin to the ground. So if we connect the corresponding output to the ground, the number will be displayed. So if we want to show number 1 on this display, LED B and C have to be turned on. So we connect output B to the ground and output C. If we connect B and C, not output, input, sorry, input B and C to the ground, because the other side is connected to VCC. So if we connect it to the ground, we see number 1. We have different type of LEDs, which is common cathode, which all of the LEDs are connected to the ground, and in order to turn them on, we need to connect the inputs to VCC. Okay, it depends to the the type of display that we have. By the way, we use it to represent, to show number 0 to 9, but we should know that we also are able to show some other alphabetic codes on this display. Fortunately, we can represent all 16 digits of hexadecimal on this LED. So number 1 can be represented like this, number 2 like this, number 3 like this, number 4 is here, number 5 is here, number 6 here, number 7 here like this or like this, number 8, the only number that we have to turn on all LEDs, number 9 like this or like this, number 0, which is here. And if we want to continue up to 15 for hexadecimal, this digit A can be represented like this, digit B can be represented like this, digit C can be represented like this, digit D is here, digit E, and of course digit F. So we see that we can show hexadecimal numbers also using these 7 segments. Okay, now that we learned 7 segment display and BCD coding system, I want to talk about a new a type of decoders. We know what is the decoder. Decoder gets an input and convert it to up to 2 to the power of n output. Okay, so